Let us continue ionic equilibrium. In ionic equilibrium, we have seen buffer solutions. Now we will see in the buffer solutions how it resists the change in pH. That we will see. How the buffer solution resists the change in pH on adding acid or base. That we will see. Okay. Now we will take a suppose we are taking acetic acid and sodium acetate. This buffer solution we will take. We have taken so and so buffer solution. Acetic acid plus sodium acetate buffer solution we have taken. To this buffer solution we are adding acid. We are adding acid. On adding acid, pH is not changing much. pH changes to very small extent. pH is not changing much. Why? That means we are adding HCl in the sense this HCl will dissociate as H plus ions. This H plus ions should not be present in the solution free. If it is present in the solution free, what will happen? pH will change. If it is not present in the solution, then pH will not change. Isn't it? We are adding HCl. That HCl gives H plus ions in the solution. If the H plus ions present free in the solution, then pH of the solution changes. If H plus ions are not free in the solution, if H plus ions are not present in the solution, if added H plus ions are removed from the solution, then pH will not change. So we are adding HCl, that HCl gives H plus ions, that H plus ions will be removed from the solution. How? How this buffer solution removes the added H plus ions in the solution? That we will see. Okay, sir. Now we will consider acetic acid 1 molar, sodium acetate is 0.1 molar, and the buffer solution is 1 liter. We added how much HCl in the sense suppose 10 power minus 3 millimole of HCl we added. Okay. Now first we will find pH of this buffer solution. Then we will say on adding HCl how the pH is changing. Whether the pH is changing normally or to very small extent, how it is changing we will see. First we will see what is the pH of this buffer solution. How to find pH of buffer solution, that we will see. Okay. In this buffer solution, what is there means acetic acid is present and sodium acetate is present. This acetic acid is a weak acid and sodium acetate is a salt of this weak acid and strong base. Okay. How to find pH of this buffer solution, that we will see. In this buffer solution, what are the species present means one is acetic acid. Acetic acid is present. This undergo ionization in the buffer solution. On ionization, it gives acetate ion and H plus ions. Now, sodium acetate present in the solution. That sodium acetate ionizes to give acetate ion and sodium ion. Sodium acetate, how much we have taken? 0.1 molar. How much sodium acetate ionizes? How much sodium acetate dissociates? Almost complete. Why do we say almost complete? Because they have not mentioned how much is ionizing. That's why. Okay. If salt is ionizing to how much extent is not mentioned means we have to say complete ionization. Okay, sir. Now sodium acetate ionizes completely. It gives 0.1 molar acetate ion and 0.1 molar sodium ion. Now we will see acetic acid. Acetic acid initially how much present in the sense 1 molar is present. Acetate ion how much present in the sense 0.1 molar from the salt, from sodium acetate salt. H plus not there. Now acetic acid is dissociating. How much acetic acid dissociating in the sense alpha molar we can say. Alpha molar acetic acid is dissociating. Okay. Now acetate ion is not dissociating, H plus is not dissociating. So how much present at equilibrium? At equilibrium if you see 1 plus alpha. Acetic acid how much present means 1 plus alpha. Acetate ion how much means initially 0.1 present. Now alpha produced. Alpha produced. How alpha produced in the sense acetic acid dissociating to alpha extent. So how much acetic acid dissociating, that much acetate ion is produced. So initially 0.1. 0.1 is given by salt. Sodium acetate salt gives 0.1 molar acetate ion, that we have written. Then how much H plus present means alpha molar. How much acetic acid is dissociating, that much H plus is producing. Okay. So now we can say for this dissociation, for this equilibrium, we can say equilibrium constant Ka is equal to right side what is there, acetate ion, right side acetate ion is there, and H plus ion is there, and left side what is there means acetic acid is there. Left side acetic acid is there. Okay. Now we can write this Ka is equal to acetate ion is how much means 0.1 plus alpha. Otherwise we will write acetate ion. Acetate ion we will write it as ACO minus. This H plus we will write H plus by left side what is there means acetic acid is there. That acetic acid we will write. Okay. Left side we will write this acetic acid. Then in this place we have committed one mistake here. It is minus because initial concentration is 1 molar. Dissociating alpha means remaining will be 1 minus alpha. Now, so Ka, acid dissociation constant Ka is equal to so and so we have written. Okay. From the now we will write this as this Ka is equal to this acetate ion concentration. We will write it as a concentration of salt. Concentration of salt we will write. Then this H plus concentration we will write by this acetic acid concentration. We will write it as weak acid concentration. Initial concentration of weak acid we will write. Why we have written like this? This acetate ion we have written as salt concentration. Salt concentration in the sense this 0.1 molar, not 0.1 plus alpha. Why we have not taken 0.1 plus alpha here? Why we are taking 0.1? Similarly, this weak acid concentration we are taking as a initial concentration of this weak acid. Initial concentration of this weak acid, that 1 molar we are taking. We are not taking 1 minus alpha molar. Why do we do like this? That we will see. Okay. Now, to understand that, first we will take a 0.1 molar aqueous solution of acetic acid we will take. 0.1 molar aqueous solution of acetic acid we have taken. Okay. Now, this acetic acid we can write it as ACOH. This dissociates to give acetate ion and H plus ions. Initial concentration of acetic acid is 0.1 molar. How much dissociating means X molar dissociating. So how much present at equilibrium? At equilibrium how much present means 0.1 minus X. Here acetate ion how much produced means X molar produced. H plus produced X molar. Now we will take equilibrium constant, that Ka is equal to concentration of acetate ion into concentration of H plus ion by concentration of acetic acid. Ka value roughly we will substitute 10 power minus 5. Roughly 10 power minus 5. Acetate ion is X, H plus is X, acetic acid is 0.1 minus X. Now you say that shall we say 0.1 minus X is nearly equal to 0.1 here? 0.1 minus X is nearly equal to 0.1 we have taken. That means X is negligible to 0.1 we have taken. Sir, X is negligible to 0.1 we have taken. Now we will see 10 to the power of minus 5 is equal to x into x by 0.1. Therefore, x is equal to 10 to the power of minus 3 molar. We got x is 10 power minus 3 molar. Okay. Now we will see, we have neglected x, whether it is correct or wrong, we will see. Now x is, this x is negligible to 0.1 we said. X is how much? 10 power minus 3. X is 10 power minus 3. X is 10 power minus 3. So we can say that is negligible to 0.1 we have taken. Okay. That means in the denominator, what we have taken in the sense, initial concentration of acetic acid. Initial concentration of acetic acid we have substituted. Actually, it is called, this denominator is called equilibrium concentration of acetic acid. That's what we have substituted 0.1 minus x. But we have neglected x, so we got 0.1. Now, the 0.1 in the sense, we have substituted 0.1. We have substituted 0.1 in the sense, we have substituted initial concentration of acetic acid. Isn't it? Sorry. So we got like this. Now, can we neglect this x always? Can we neglect this x always? That means, if the initial concentration of acetic acid is greater than 0.1, then what shall we do? If it is greater than 0.1, suppose, let us take this is as a 1 molar. If we take this is as a 1 molar, then we cannot neglect x when compared to initial concentration. If we take this initial concentration as 1 molar, then we can't neglect x. Suppose if we take initial concentration is still less, that means 0.01, then we can neglect x. If we take 0.001, we can neglect x. If the concentration is greater than 0.1, then we cannot know. Therefore, we have to see that initial concentration we have to see. At the same time, we have to see even equilibrium constant also we have to see. Suppose I am taking like this. I am taking HSO4 minus gives H plus SO4 2 minus. Like this equilibrium I will take. Initial concentration of bisulfate I will take 0.1 molar. It is dissociating x molar. So how much remaining means 0.1 minus x at equilibrium. H plus produced x molar, sulfate is produced x molar. Now equilibrium constant for this equal to concentration of H plus into sulfate concentration by concentration of bisulfate. Now equilibrium constant is roughly 1.2 into 10 power minus 2 for this. Now we will write H plus concentration, sulfate concentration, bisulfate concentration. Bisulfate means concentration at equilibrium. Okay, so concentration at equilibrium we have substituted. Now we have substituted here 0.1 minus x we have substituted here. Okay, this x will be, this x value we will compare with this 0.1. This x we will compare with this 0.1. Can x greater than 0.1? Not possible. Why? Because we have taken 0.1. We have taken 0.1. In this, some amount is dissociating. Otherwise, complete dissociation. More than that, is it possible? No. Therefore, x can be equal to 0.1, one possibility. X can be less than 0.1, another possibility. X cannot be greater than 1, greater than this 0.1. Isn't it? Okay. Now, we have substituted here equilibrium concentration of bisulfate as 0.1 minus x. Now, you say that, shall we take 0.1 minus x nearly equal to 0.1? Shall we neglect x when compared to 0.1? Sorry, whether it is correct or wrong, we will check it. Let us neglect, then we will check whether it is correct or wrong, we will check it. Okay. Sorry. Now we will neglect this x and we will proceed. So 1.2 into 10 to the power of minus 2 is equal to x square by 0.1. Now, if you simplify, you will get x. That x, if you see, then you can come to know that we should not neglect x when compared to 0.1. Now here you see, we should not neglect x when compared to 0.1. Suppose if initial concentration is 0.001 molar, then we can neglect. So whether we have to neglect this x, or not, that depends on what, in the sense that depends on this initial concentration as well as this acid dissociation constant. Okay, depending on these two values only, we have to conclude that whether to neglect or not to neglect. Okay, so we have to consider initial concentration of bisulfate and Ka. These factors we have to consider, then only we have to say whether to neglect X or not. Okay, sir. Now I will take 0.1 molar aqueous solution of acetic acid. This acetic acid dissociates to give acetate ion and H plus ion. Initial concentration is 0.1 molar. How much dissociating means X. How much remaining means 0.1 minus X at equilibrium. Acetate produced X, H plus produced X. Now I will take equilibrium constant Ka equal to concentration of acetate, concentration of H plus by concentration of acetic acid. Ka value roughly I will substitute 10 power minus 5, acetate ion X, H plus X, acetic acid is 0.1 minus X. Now I will take 0.1 minus X is nearly equal to 0.1. Now I will simplify, I will get X is equal to 10 power minus 3. Okay, sir, I got X value. So X value how much in the sense 10 power minus 3. So I will write here 10 power minus 3, here also 10 power minus 3. This I will write it as 0.1. Okay, so I am writing here 10 power minus 3 molar, here 10 power minus 3 molar, here I will write 0.1 molar. Okay, like this I have written. Then to this, let me add 0.10 power minus 3 millimoles of HCl. 10 power minus 3 millimoles of HCl I will add. Otherwise, I will add 1 mole of HCl. I will add 1 mole of HCl. This is 1 liter solution. This acetic acid solution is 1 liter. I am adding 1 mole of HCl into this. So what will happen? Now I will see. Okay. So we will take this one. This acetic acid gives acetate ion and H plus ion. This acetic acid is 10 power minus 1 molar in 1 liter solution. Therefore, number of moles will be 0.1 mole. 0.1 mole. Acetate ion is 10 power minus 3 molar, 1 liter solution, therefore 10 power minus 3 moles. 10 power minus 3 moles. H plus is 10 power minus 3 molar in 1 liter solution, therefore 10 power minus 3 moles. Now we are adding HCl. HCl dissociating completely because it is strong acid. It dissociates to give 1 mole HCl. So 1 mole of HCl gives 1 mole of H plus ions. So how much H plus ions are there means 1 plus 10 power minus 3 moles. How much acetate ion means 10 power minus 3 mole. How much acetic acid means 0.1 mole. Now we will see QC value. We will find QC. QC is equal to concentration of acetate ion 10 power minus 3, concentration of H plus 1 plus 10 power minus 3. Okay, concentration of acetic acid 0.1. Now you say that QC and this KC we will compare. This QC and this KC we will compare. We can say QC is greater than KC. QC is greater than Kc in the sense that system is not at equilibrium. This system is not at equilibrium. Equilibrium is disturbed. Here system were in equilibrium. Now system equilibrium is disturbed. Disturbed in the sense it will favor forward or backward. Backward. Backward is favored. So we are saying that backward is favoring. We are saying so backward favors. So backward favors in the sense in this place the system will attain new equilibrium. Okay, so system goes for a new equilibrium we can say. Okay, system goes for new equilibrium. Now backward favors in the sense y molar H plus disappearing, y molar acetate disappearing, y molar acetic acid is producing. Therefore acetic acid 0.1 plus y, acetate ion is 10 power minus 3 plus y, and H plus is 1 plus 10 power minus 3 plus y, and that means minus y we have to write here minus because disappearing here, therefore minus we will write here minus. Here we can write it as a minus y we will write. Okay, so now Now we will find what is the value of y we have to find. What is the value of y? Let us find. Okay. So for which we will take equilibrium constant. Equilibrium constant is what in the sense Ka. Ka is equal to concentration of acetate ion, concentration of H plus ion by concentration of acetic acid. Okay. Ka roughly we will take 10 power minus 5. Acetate ion concentration is how much? Means 10 power minus 3 minus y. Okay, it is moles. Volume of solution is 1 liter, therefore concentration is this much. Okay, so 10 to the power of minus 3 minus y, it is acetate ion. H plus is how much in the sense 1 plus 10 power minus 3 minus y. Then acetic acid how much in the sense 0.1 plus y, 0.1 plus y. Okay, so acetic acid is 0.1 plus y, we can say. Sir, we have substituted everything. Now we have to find y. Okay, we have to find y in the sense we have to neglect some of the terms. If we neglect some of the terms, then only we will get y we will get. Okay, so what are the terms we will neglect? What are the terms? Let us neglect, that we will see. Okay, now this 1 plus 10 power minus 3, 1 plus 10 power minus 3, we will take it as 1. Then what will be there means then 1 plus 10 power minus 3 minus y also we can take it as 1. How? Because equilibrium constant is 10 power minus 5, therefore this y is negligible when compared to this 1, therefore we have taken. Sorry. Then I will take this 0.1 plus y is also negligible to is also nearly equal to 0.1. I will take. Whether it is correct or wrong, we will check. Now we can say 10 power minus 5 is equal to 10 to the power of minus 3 y by 0.1 we will take. This we have taken nearly 1. Okay, so we will simplify. 10 power minus 6 is equal to 10 power minus 3 minus y we have written. That means we can say even 10 power minus 3 10 power minus 3 minus y is also nearly equal to 10 power minus 3, we can say. Why? Because you see this, how this expression is there, you see. So 10 power minus 3 minus y is also nearly equal to 10 power minus 3, we can say. That means what we have done in the sense this acetate concentration is nearly equal to 10 power minus 3 molar. This H plus concentration is nearly equal to 1 molar. This is nearly equal to 0.1 molar. Isn't it? Okay. So we are taking here we have added 1 mole of HCl. Therefore, in the new equilibrium, what is the concentration of H plus in the sense 1 molar? Acetate ion is 10 power minus 3 molar. Acetic acid is 0.1 molar. Like this we have taken. Sir. So due to addition of HCl, what had happened? Due to addition of HCl, what had happened to the dissociation extent of acetic acid? That's what we said, backward is favored. Therefore, backward is favored in the sense that dissociation of acetic acid decreased, we said. Sir. So like this is there. That means if we add HCl into acetic acid solution, we said backward is favored. Backward is favored in the sense acetic acid extent of dissociation decreases. Okay, acetic acid extent of dissociation decreases. This effect is called common ion effect. Why it is called common ion effect? Because we added H plus into this solution. We added H plus into this solution. That H plus already present in this solution. So what is present in the solution, that we added. Okay, so what is present in the solution, that if you add, then you have to say common ion we added. What is the common ion here in the sense H plus? Because we added H plus, that's what present in the solution. So common ion is H plus. So due to addition of common ion, equilibrium is disturbing. That effect is called a common ion effect. Here we added common ion H plus. So equilibrium is disturbed. What is favored in the sense backward is favored. Due to that dissociation extent of acetic acid, what happened? Decreased. Degree of dissociation of acetic acid, what happened? Decreased. Okay. Suppose if you add base, what will happen? If you add base, base will remove this H plus. If you add base, base will remove this H plus. Therefore, concentration of H plus decreases. Therefore, which will favor? Forward favors. This is not common ion effect. Because we added a base in the sense OH minus. That OH minus is not present here. So it is not common ion effect. Anyhow, on adding OH minus, we disturbed the equilibrium. That's what we can say. Sir. Now we will go back to this buffer solution. We'll go. Now we have taken this acetic acid solution, 1 molar, and a sodium acetate solution. Both we have mixed. Now concentration of in the buffer solution, concentration of acetic acid is 1 molar. In the buffer solution, concentration of salt is 0.1 molar. Volume of solution is 1 liter. Now acetic acid is dissociating like this. Sodium acetate is dissociating like this. Let us consider sodium acetate dissociates completely. So now in this case, acetic acid 1 molar we have taken initially. Acetate ion 0.1 molar is from the salt. This dissociation both take place in this buffer solution. Now acetic acid, how much dissociating means alpha molar. How much acetic acid present at equilibrium means 1 minus alpha. Acetate is 0.1 alpha. H plus is alpha. Ka, equilibrium constant for this is Ka, acid dissociation constant we have written. Now acetate ion is 0.1 plus alpha. What I am doing means I am taking alpha is negligible to 0.1. Therefore acetate ion concentration is 0.1. I am saying that means that is nothing but concentration of this salt. So that's what I have written here, concentration of salt. Acetate ion I have taken as a concentration of salt. Then this acetic acid I will take. It is 1 minus alpha. Acetic acid is 1 minus alpha. I will consider alpha is negligible to 1. Then I will say equilibrium concentration of acetic acid is nothing but initial concentration of acetic acid. That's what I have taken. So in this place, for this equilibrium constant expression we have written here in the numerator, ACO minus means acetate ion concentration. That is how much means 0.1 plus alpha. That we are taking as concentration of salt. Concentration of salt in the sense of this one. That means we are neglecting which one? Acetic acid giving acetic acid contributing acetate ion. No, that concentration we are neglecting. Seriya? Okay. Because this equilibrium constant is 10 power minus 5 and common ion effect is there. That's why. What is the common ion effect? Here common ion effect, what is the common ion we added? We added sodium acetate into this acetic acid. We are adding sodium acetate into this acetic acid. Sodium acetate gives acetate ion to this. Acetate ion is the common ion here. So we added common ion. Common ion we are adding in the sense backward only will favor. Acetic acid dissociation, what happens? Decreases, no? Acetic acid dissociation decreases. Therefore, only we neglected alpha is negligible to 0.1 we said. Okay, because of common ion effect. So due to common ion effect, we can say concentration of acetate ion is nearly equal to concentration of salt. Okay, sir. And also we have to check here we neglected. For acetic acid case, we have neglected because Ka is 10 power minus 5. So that we have neglected this alpha when compared to 0.2. Suppose Ka is not 10 power minus 5. Ka is 10 power minus 2. Ka is 10 power minus 1. Then can we neglect alpha when compared to 0.1? No. Okay. Therefore, we have to see the Ka value and we have to see this concentration value, this concentration value we have to see. Then only we have to conclude whether to neglect alpha or not. Okay, sir. As per this example, I have neglected. So I have neglected alpha when compared to 0.1. So 0.1 is nothing but initial concentration of salt. That salt concentration I have substituted here. Okay. Similarly, when alpha is negligible to 0.1, why not with 1? So I am neglecting alpha with 1. Therefore, this is nothing but 1 only. So this ACOH is called equilibrium concentration of acetic acid, that I am taking as a initial concentration of acetic acid. Okay, so I have taken the formula Ka is equal to concentration of salt into concentration of H plus by concentration of weak acid. Okay, so Ka is equal to concentration of salt, concentration of H plus by concentration of acid. Okay, concentration of acid initially. Now, from this we will find H plus concentration is equal to Ka into concentration of acid, initial concentration of acid by initial concentration of salt. Let us take log on both sides. Log of H plus is equal to log of Ka plus log of acid by salt, acid by salt. Then I will introduce minus on both sides. Minus log of H plus is equal to minus log of Ka. This I will write this as plus. Then I will write log salt by acid. I will take salt by acid. I will take. Okay, I will reciprocate because of minus. Then minus log H plus we can write it as pH. Minus log Ka we can write it as pKa plus log concentration of salt by concentration of acid. This is called Anderson equation. It is called Anderson equation. Anderson equation. This equation is used for pH of buffer solution. Okay, so pH of buffer solution is equal to pKa plus log salt by acid. Okay, for acidic buffer we have taken a acidic buffer we have taken. Suppose if we take basic buffer, how to find pH of that solution, that we will see. Okay, so basic buffer we will take. Basic buffer in the sense, let us take ammonium hydroxide plus ammonium chloride. This buffer solution we will take. Here it is a weak base. Ammonium hydroxide is a weak base. Ammonium chloride is a salt, salt of this weak base and strong acid. Therefore, now it is called a basic buffer. For this basic buffer, how to find pH of solution we'll see. Now we will take ammonium hydroxide is a weak base that dissociates to give what in the sense ammonium ion and hydroxide ion. Okay. Now for this equilibrium constant is Kb, that is equal to concentration of ammonium ion and the concentration of OH minus ion by concentration of ammonium hydroxide. Okay. Now this Kb is equal to what we can say in the sense ammonium ion concentration we have to substitute. Ammonium ion is given by this ammonium chloride salt as well as ammonium hydroxide. This ammonium chloride gives ammonium ion. That ammonium ion is common ion for this equilibrium. Due to common ion effect, here backward is favoring. Therefore, ammonium hydroxide degree of dissociation is reducing. Therefore, concentration of ammonium ion from ammonium hydroxide is negligible we are taking. So, concentration of ammonium ion is mainly from salt concentration we will take. Therefore, in the place of ammonium ion concentration, we will write a salt concentration. We will write. Then we will write this OH minus by concentration of ammonium hydroxide is nothing but this weak base initial concentration we can say, because the extent of dissociation of ammonium hydroxide is decreased because of common ion provided by this ammonium chloride. This ammonium chloride salt provides common ion ammonium ion. Due to that common ion, extent of dissociation of ammonium hydroxide is reduced, we can say. Okay, so this ammonium hydroxide is a base, that concentration we'll write here. Okay, so now we will take a log on both sides and we will get a OH minus concentration. Then we will get POH. POH is equal to what you will get in the sense pKb plus log salt by base you will get. Salt by base. Okay, so here this is for basic buffer. For basic buffer, pOH is equal to pKb plus log salt by base we got. For acidic buffer, pH is equal to pKa plus log salt by acid we got. So acidic buffer means pH, here acid. Basic buffer means pOH, here base. Okay, it is called Anderson equation. So using this equation, we can find what in the sense pH of buffer solution we can find. Okay, sir. Now we will take a 1 molar acetic acid. This is 1 liter will take. 1 molar sodium acetate will take. This is 1 liter. Let us mix both. We will get buffer solution. Now, what is the pH of this buffer solution? Let us find. Okay. So, 1 molar 1 liter acetic acid solution we have taken. 1 molar 1 liter sodium acetate solution we have taken. We are mixing both. We got buffer solution. For this buffer solution, what is the pH? Okay. So, pH is equal to, what is the formula? pKa plus log salt by acid. Salt by acid concentration. Salt by acid. Okay. Now, we let us substitute. pKa value we will substitute. pKa in the sense Ka is called acid dissociation constant of acetic acid. That is constant value that we can take. Okay. Plus log. Salt concentration let us substitute. Okay. Now, this 1 molar and this 1 liter let us multiply. Therefore, 1 mole. Okay. 1 mole of sodium acetate. So, in this buffer solution, how much sodium acetate is there? 1 mole of sodium acetate is there. 1 mole of sodium acetate is there. That 1 mole we will substitute. 1 mole of sodium acetate by volume of solution will substitute because concentration. Okay. Here 1 liter, here 1 liter. Therefore, volume of solution is 2 liter. That 2 liter will substitute. Then acid we have to substitute. Here this 1 molar, this 1 liter we will multiply. We will get 1 mole of acetic acid. So, in the buffer solution, how much acetic acid present in the sense 1 mole of acetic acid is present, that we will substitute, and the volume of buffer solution is 2 liter, that we will substitute. This 2 liter get cancelled. 1 mole means 1, log 1 is 0. Therefore, pH is equal to pKa. Okay, pH is equal to pKa, we can say. So, Ka is how much in the sense Ka is equal to 1.8 into 10 to the power of minus 5, that we will substitute. So, it is equal to minus log of Ka. Ka is 1.8 10 power minus 5. This if you simply you will get pH 4.74. Okay. So, pKa is equal to how much in the sense 4.74 we can say. So, what is the pH of this buffer solution in the sense that is equal to pKa, because salt concentration is equal to acid concentration. In this place, we need not substitute concentration ratio. We will substitute mole ratio. We can substitute. Why? Because anyhow volume is getting cancelled. Volume of buffer solution here, volume of buffer solution in this case remains same. Therefore, volume will get cancelled. So, instead of concentration ratio, we can substitute mole ratio itself. We can substitute. So, now we got how to find pH of the buffer solution. We got now to the buffer solution. If we add acid, what will happen to the pH of buffer solution? We have to see. If we add base, what will happen to the pH of buffer solution? That we have to see. Okay. Then, if change takes place, is changing normally or a very small extent? That we will see. Okay, sir. Now we will take a buffer solution. We are taking acetic acid plus sodium acetate. This is 1 molar. This is 1 molar. Here 1 liter solution. Let us add 10 power minus 3 millimoles of HCl. This many millimoles of HCl we are adding. For this, we have found pH is equal to how much in the sense pKa, that is equal to 4.74 we have found. Now we added HCl. What will happen? We'll see. This acetic acid is dissociating to give acetate ion and H plus ion. Here how much acetic acid is we have taken in the sense 1 molar into 1 liter, that means 1 mole. How much acetate ion means 1 molar into 1 liter, that is 1 mole. Acetate ion is 1 mole.